and we do some practice, of course. No, my machines, no one want to boot this morning. Okay, gonna give them time. So DNS, we already studied DNS in block 1. If you remember, let's refresh this whiteboard. Right. We had some few basic explanation before, and let's review them before going further. Computers, right? Computers in the cloud, the internet. So computers need to talk to each other's using IPs, right? IP1, IP2. Okay, but human need to use to get access, for example, to server or any other computer based on names, right? Those can be URL, can be UNC names, and so on and so on, right? Host names. But we need names, and those names, for example, if there is a web server here that's gonna be www something.com, the computer should know and understand what is this thing, because he need the number associated to these names, right? So computers to be able to talk and send those packets and payloads to ask something and get an answer back, right? Some other packets to get a result or anything or any service need to have the number here. Okay, either IPv6 or IPv4. But he needs that IP numbers. All right. So to be able to work between these two different forms of destinations, one is based on characters and names, and the other is based on numbers. One is adequate and good for computers, the other one is better for human being. We need a kind of translator or a phone book or IP book. Well, we call it the DNS, right? DNS, domain name server. And this domain name server, he gonna have name associated to IP, name 1, IP1, name 2, IP2, and so go on. So when anybody gonna ask for a name, for a specific name, for something, somewhere, he will reply by the IP, and he will tell, oh, okay, the one that you are looking for here, name 2, is IP2 associated to him, so the machine can talk to this guy, right? Okay, so this is just a refresh. It's just a refresh. We had that structure also of the computer names that we call them FQDN, right? Full qualified domain names, that they are hosts dot domain dot TLD, and in this TLD we have two kind of TLDs. We have country codes and we have generic one, right? The country code can be EN for India, CA for Canada, US for United States, and so on and so on. Okay. Generic can be COM, GOV, EDU, for education, and so go on and so go on. EO, a lot of them, .finance, .something, especially since a couple of years or more, a little more, 4 or 5 years, they opened the TLD generic names, right? Before we had like 8 or 10 generic names that we can use. Now we can use whatever we want. Cinema, money, right? So they opened it. Okay. So those we call them TLD for top level domain, right? Top level domain. So this is a refresh, right? This is a little review. See in our document here what we are. Okay, my computer's boot up finally. So let's see what's in here. So users and computers use host name rather than IPv4, IPv6 network addresses to communicate with other hosts and services on the network. Windows Server 2016, 2020, 2090, 2003, 2008, all of them service known as a domain name system or DNS resolve the name to IPv4, IPv6. We just explained that. Okay, nothing new. Of course, name resolution in the server 2006 or whatever does more than just provide for sample name IP mapping. DNS server role is also used by computer to locate services within the network infrastructure. Yeah, for example, who is the domain controller? Where is the Kerberos computer that I can ask for? What is the email server for Exchange that I can communicate and send email through, right? So he can also locate services. Name to IP mapping. The DNS role also is the computer to locate services within the network infrastructure. For example, when a computer starts up, user must sign in to the Active Directory and perhaps open Microsoft Office Outlook for messaging. This means that the client computer must locate a server that can provide authentication. Of course, otherwise you will not be able to log on in the domain or a domain controller. So we need to verify his account, we need to verify his password, and even the computer need to be approved and authenticated on the Active Directory. So this computer belonged to the domain and he had the right to log on, someone log on through that machine. So all those are protocols that they are validated by a domain controller, right? We can locate through the DNS who is that guy, right? And if we have a messaging, for example, in module 5, we're going to do that. Last module in this block, we're going to study Exchange server. And we're going to need a row code called MX, for example, right? For Microsoft Exchange. Right? When they need an email, okay, they're going to ask a DNS. Who is the server Exchange here around? And they're going to give him the address. This means that the client computer must locate a server that can provide authentication service in the local Active Directory domain and services site, etc. Locate the appropriate Microsoft Exchange mailbox server. Where is the mailbox? That I can check my mailbox in there. For the users, DNS is in port 53. This is a reminder here. DNS is in port number 53. Host names. A host name up to 255 characters in length contain only alphanumeric characters, periods, and hyphens. A host name is an alias combined with the DNS domain name. For example, the alias computer1 is prefixed to the domain name contuso.com to create the host name of a fully qualified domain name, FQDN, computer one, right? So this is the host. Dot, see that we can use periods. So period, contuso, period.com, then a TLD or top level domain here. This is a generic one. And this is my domain name, right? So it's the same, exactly the structure that we were talking about here. A host, the domain, top level domain, right? Or we can point an alias here, like we were doing for www. Okay. But this is the computer host. So what is the structure of this host? Names up to 255 characters in length. Contain alphanumeric, so we can use alphabet, we can use numbers in there. Separated by periods, we can put periods in there, and hyphens, we can use hyphen. Yup. For example, if I have my computer one, so I can use computer hyphen one, computer. So those structure of names, they accept hyphen in that, right? Computer -2, just 3, right? So I can use hyphens or dash. Sure. But 255 characters, alphanumeric ones. Can use periods inside. Yeah, computer one period contuso period com or dot. Can put hyphens in there for the host names or even the domain if you want. And this is what we call a full qualified domain name. NetBIOS names, on the other hand, just the computer names, use a non-hierarchical structure based on 16 characters. We studied this before in block 1 also. It's just a reminder. So it's a 16 characters non-hierarchical one. It's just a name like Hamza, like cloud, like sand or water, right? It's just a name of 16 characters. And this one become the host here. We can put another alias for him. Yeah, we have the freedom to do that. But in reality, this is what we take. So what computer has its own NetBIOS name, and we're gonna just use that host name here, NetBIOS name dot something dot something. The 16th character identify a particular service running on the computer, of course. So we use Wins server to resolve those services based on their NetBIOS names. Name resolution process. So what is the process to resolve those names? To determine whether the acquired host name is in the local file host. Yep. Remember, guys, just refreshing your memory. Locally in each computer, there's my Windows 10. I'm gonna just log on. Locally in each computer, we have a file named host file. Host file. Right, in C, Windows, System32, etc. And we're gonna find something called host. And that file is just a have some text inside, right? So we can put in a name, associate an IP to a name, and it's local. It's local in each computer. So this is computer one. Right. Now, if somebody gonna type anything here, for example, www.google.com. Well, first of all, where this computer gonna check for google.com is in the host file. Right? So you're gonna see if this information is already available here in this file or not. Right? And second of all, you're gonna go to the browser cache. Cache of the browser. If it's available in there, we'll not ask any DNS. If it's not, he will go to the DNS. That is, of course, configured in the TCP IP of the computer. Right? So we need to point this computer to a DNS server IP here. So we'll be able to go and check here and ask that DNS or domain name service or server for that information and ask him, hey, do you know what is google.com? www.google.com. And of course, if the record exists here, we're going to call it a record. I'm going to see the kinds of the records after. Right? I'm going to say that, okay, we have something called www.google.com. I just pointed to this IP, IPG for IP Google, and it will give him back that IPG. So this computer will be able to go to that IPG address and check google.com. Ask him for HTTP request, for example. Now we're going to study further also. Okay, so he will come back with some answer here and packets for answer, and he will display for you the website. We see that the process is not just the DNS directly. We go to some services before, so search and determine whether the acquired host name is in the local host file. And here's my Windows 10, so you can see and review together. We already saw this before. And system 32. Drivers, and let's see. And here's my host that of course I can open with. I can open with Notepad, and here's the information, just some information here that I can add some IPs. I can say, for example, hey, 10.10.10.10 now. This is www.google.com. Right? So this computer, when he will try to go to Google, he will just go to 10.10.10.10. He don't care what is in the cache, what is in the DNS or whatever. He will not even ask the DNS for it anymore because the information is already available here, right? So anything that we're going to put manually here. So first of all, this host is personal to this computer. So it's not centralized service that can provide solution for many computers clients, right? So this is the first difference between this host and DNS. So it's not a centralized service and solution. He will provide just the computer where he's configured to there, right? It's not like a DNS that can help a park of computers or any infrastructure or platform of computers, that any computer that is pointed to him will be able to provide him an answer. But this one, he just resolved for this computer, this one, right? Will not resolve for any other. DNS can be updated dynamically from a DHCP, from Active Directory, from many other stuff, right? So the records that they are inside, they can be updated dynamically. The host is updated manually. Okay. There's no dynamic update for the host file. So we need to come here and put some informations by ourselves. So the informations are entered in the host file manually. A second step here, search the local DNS resolver cache for the acquired host name. The cache is updated when a record is successfully resolved. In addition, the content of the host file is added to the resolver cache. Yeah, all the kind of caches. There's also in between here the browser cache now, because browsers have their own cache. So when they already visit a website before, they will not ask anymore for that, right? It's the same thing. Like, for example, if you just get the phone number, right, and you call that phone number, okay, so you had that phone number noted in paper before. You copied that phone number in your phone and you deal that number, right? 514 something and something and something. Okay, and tomorrow you needed to deal that same number for that person. You didn't really added it to your contact. It's not a contact, right? So it's just a occasional something that you need for that number. Check in for a new apartment or something like that. So tomorrow when you go to your phone, you don't need that paper anymore to tape it, right? The phone number is already in the cache, registered in the cache. If you go to a recent call in your phone, you're gonna find that number in there. It's the same thing that those browsers work. When you already resolve something, so the browser is gonna keep that information in like the recent call or the recent names, but it's not named like that. It's named a cache browser, right? So that information is already there. And even if you already checked on the DNS here, what he's talking about? He's talking about something that we're going to check after for the recursion request. All right. When you have a computer that gonna talk with some DNS, let's say we are on Herzing, right? This is a computer 105 teacher. I'm on room 105 in Herzing, and we have our DNS. It's in our room server on Herzing, right? So this is a Herzing DNS. Great. Now, I'm looking for www some website.com. And that website, the record doesn't exist here in this DNS of Herzing. So Tau DNS don't know the IP address, right? So what are you gonna do? You're gonna ask all the DNS. For example, first of all, you're gonna ask the ESP1, right? And if the ESP1 know what is the IP address, he will tell him back. But if he don't know the ESP1, he will tell him where is the .com, right? So he will go to the .com one. And he will ask the .com one for what is this domain, right? And the .com one will answer to him with the IP address of some domain. And he will ask the some domain, and the some domain will answer back here with the www. So this guy gonna tell the computer what is the www, and he will be able to communicate with this website here. Well, here when the DNS check for those things, he gonna also cache those informations, right? So the next time when I'm gonna ask him for 105 something, he will just check in the cache first. Oh, well, we saw this yesterday. I already acquired this query here, and I already know that the IP is IPS here, for example, right? So he's gonna just give you from the cache. So this is what he's talking about here, right? CH, the local DNS is over cache first, right? So if the local DNS already resolved this before, he will not go to other DNS to resolve it because the information is already in the cache. All right, so the cache is updated when the record is successfully resolved. When something is successfully resolved, the cache will be updated with that information and it will be kept inside. It will be kept. In addition, the content of the local host file is added to resolver cache. Yep. So if there is any resolving information on that DNS that we did add here. Right. So imagine that I'm going to go here and I will add something to this host, right? Manually or something like that. It will be updated on the cache of the DNS also, right? Petition a DNS server for the required host name. So not that the local host file have priority over DNS. Yeah, we know that. We already studied this. Remember, host file have priority over the DNS. So this is a third different points between the host and the DNS. We said that the host file can't be dynamically updated. It's manually updated. Host file is not centralized. It's not centralized. It's just for one computer. And now we know a third difference here. The host file is have priority over the DNS server. So this is a process here, local host file, cache, any kind of caches, right? Browser cache, DNS cache, whatever cache. And after we go to the recursive queries on the DNS, right? Server DNS. So the DNS is a role. Keep it in mind, DNS is a role that we install on the servers. DNS server can be server member or DAC. Yeah, so we can have that role in a domain controller like this one. So you see this one. When you upgrade a computer to domain controller and you create your domain, for example here, originx.com, PDC1, he will install a DNS automatically. There is no domain controller without DNS, doesn't exist. Domain controller or any domain is all the infrastructure is built on top of a domain, right? And yeah, so this is for the trust last time that we did it. And you see that this origin X here, when I upgraded this computer to a domain controller, he created this zone by himself. Those are the stations that they join the computer. This is the second domain controller, and this is PDC1 right here, the domain controller, right? And all this zone, this is a child zone, RX1 that we did together on last module. So this is a computer from your last module. Okay, so I see that I have a server here, another server, and those are the addresses assigned to those servers. I have two clients here, right? And I have a name server, start of authority here. I'm going to talk about them again one more time today. But this is an Active Directory zone. This is an Active Directory zone. So you see here, when I go to property, he's saying that status is running, and the type of this zone is an Active Directory integrated zone. So it's an integrated, this zone is integrated to an Active Directory. Okay, replication, all DNS, so we can change to whom it will be replicated. And this is a difference between a DNS Active Directory zone and a normal zone in a standalone. A normal zone in a standalone is just a zone on that computer and that's it. So it doesn't belong to any domain. An Active Directory one, it's gonna replicate automatically to all or few, depending how we configure it, other domain controllers. Gonna replicate automatically in all the domain controllers on that domain. So if I have more than one, it will be replicated. Like here, for example, I have this DC and I have DCX2. This one is a second domain controller in there. So since this one is an Active Directory and the other one is an Active Directory, and you see here by default, where is it? Here we go. So to all DNS server running, domain controller in this domain origin.com, which by default gonna replicate, change replication zone. So it's an Active Directory integrated one. I can put it out. It will be a very bad idea to do that because it's the Active Directory zone. It's the real one, right? So I should have, it's the one that resolve originx.com, okay, my domain. All right, so I shouldn't play with this here. I can do it with all the zones that I create if I want to integrate them inside or not, but especially this one, no, because it's gonna destroy a lot of things in my Active Directory. This one is dead here. I'm gonna refresh it. All right, so you see this is a second domain controller in Origin X. And of course, he's gonna have his own DNS copy. And you see that the DNS can have dynamic updates from DHCP or from Active Directory domain and controller. So users and computers, sorry. So if I'm gonna add a computer here manually, or any computer gonna join will be updated, like station 1 and station 2. I didn't add this record in there. That was being updated automatically in here. Host file can do that, right? It don't have the capacity to talk with other services and update himself based on what is in you. You see that is the second DC here in Origin X, the same domain controller, same domain, sorry. And you're gonna see that you're gonna have that Origin X here. There we go. So, and it's the same records. There's a replication in between. Okay, so it's exactly the same record in the same zone, primary, Active Directory 1. Okay, replicating to all DNS here. Right. And those zones are created, even the DNS installed automatically when you add a role. And for example, here I'm gonna take another computer and we're gonna try to do it together. So I think R1, X1, X1, 1, 3. Okay, so this is the oldest one. Let's play with this machine quickly here, trying to review quickly also how we add the role of DNS, and we gonna go further after. So no merge. So DNS server can be server member or DC. So what is a server member? When I have a domain, so let's say this is my domain controller, DC, and I have a domain d1.com, right? Okay, I can join clients, right? I can join clients. We saw it in last module. So I can have Cli1 here that gonna join D1, and he will be Cli1.d1.com, and he will be client. Okay. So this is a client, station 1, station 2, this is Windows 10. Now, if I have a server, this server can be, for example, DC2, like we did here with DCX2, right? So I upgraded a second domain controller in my domain, and he will have Active Directory, users and computers, he will have a DNS, and so go on and so go on. Good. Imagine I have another server, but instead of upgrading as a domain controller, I will just join the domain like I did with the client here, right? Same, but he's not Windows 10, so this one is Windows 2020, for example, right? This is a member server. This is what we call a member. So he's a server, but he's not promoted. He's not promoted to domain controller. He gonna join like a client. Okay, and I can have a DNS here. This is what he's saying, but this word is what he mean here. Can be a server member. Server member, this means he's not promoted as a domain controller. He's just a member of the domain, but he's not client. He's a server, so he can be DHCP. He can have a lot of things. So he can build here an FTP or something like that, web server. Okay, but he's a member server. He's not a domain controller. Okay, he don't have a schema. He don't have a REAP or deep or whatever. Global catalog. He don't have Active Directory uses and computers and dominant services, nothing. He will just join as a member server. Okay, like the client join. So we go on property and we join the domain. Here also, we're going to go to the property and we join the domain, and that's it. This is called member server. We have other kind of server that he's not any member or anything. He's just outside. Right. This called standalone server. Right. So this is the words for them. Okay. This is a domain controller, the second one. So he's promoted. This is a member server. He's not promoted as a DC, but he belongs to the family, right? So, but he's a member, like the client here, so we can use his services, but he's not powerful. He don't control the domain. And another one that he's not in, neither in the domain, he's not member, he's not DC. When I have just a server like this, we call it standalone server, called a standalone server. So this is what he meant by member server here. So server can be DNS. In an organization, he can be a server member. So we just join a domain, a server, we join domain, and we add the role of DNS, and he's gonna play a role of that DNS server. Or he can be promoted as a domain controller. The DNS role is mandatory for DC. Yeah, we can't have primary domain controller or second domain controller without the DNS. It's mandatory. He should have when we install a domain controller, we should have a DNS. We saw it in last module. We talked about this before. DNS is a role. Yeah. Okay. So we add the role that we add. By default, the DNS implement its folder in the following path location. Windows root, so C system, for example, if I have my system in C drive, so C system32 DNS, and we're going to find all the files in there. Right? I have a domain here. C26. Should be a router, this one. Just checking what is in there. Maybe you're gonna use another machine. Okay, so we said here in the meantime, said that the DNS is somewhere, and we saw it before also in block one. This information is not new for us. So if you go to C drive, system32, and when we install the role, we're gonna have an extra file here called DNS. There we go. If we have the role of the DNS in any computer, and you see that I have a zone that I can open with Notepad also and see the informations that they are inside. Here we go. You see that I'm gonna see some records. I have a PDC1 and some stuff here. Region 1. Well, it's on Active Directory and cache DNS where I have my root hints here, right? By default ones, 13 of them. Well, we're gonna talk about them again. All right, so this is the location itself on wherever is your system, wherever is your system, and system32/DNS. You're gonna have the file of the database of DNS, of course, and we can open them with Notepad and see the informations that they are inside. Okay. Okay, I don't know how the hell this one become a child domain in OriginX. Not supposed to be playing in your classroom at all. You are C22. So it's my mistake on the naming. I'm gonna close this machine. Let's try this one. So we add the role. We're gonna practice this together once the machine is booted. So if the server is a DC, a domain controller, then the DNS zone with all the records corresponding to that domain with all the required information will be created and configured instantly while creating the domain. Active Directory zones, we call them Active Directory zones, like I have a domain contuso.com. So this zone is created by default in the forward lookup zone, and it's an Active Directory zone. Are replicated. So the differences are this one handle services for my Active Directory, of course. So where's the authentication server, with the mail server, with whatever Active Directory servers and so on. And they are replicated between all the domain controllers automatically. Between DCs as part of Active Directory. If I have other DCs, it will be replicated automatically. Let's see what we have in this one. Okay, this one is a standalone server. He's not a member. He doesn't belong to anything. So he's just a server, a lone one, standalone. One 172.24.100. And these guys are in Montreal, I guess. This one was router before, so I'm just moving adapters here, extra ones that I don't need. Oh, well, hope okay. Yeah, hidden merge there. That merge. Merge. There. So as you can see, this computer is not a domain controller. He's in work group, right? He doesn't belong to the domain, so he's not even a member server. He's a standalone server, right? So you change the IP address, you're gonna see that he can ping the other computers, but he doesn't belong to the organization at all. Okay. 172.24. Oh god. 172.24. 100. Let's say this one gonna be 50. I don't know what slash is here. Let's check it. Okay, slash 24. All right. So you see that like this, he's just a standalone server. Okay. He can ping the others. I don't have any relationship with any guy in there or any infrastructure or hierarchy or whatever. 24.101, and you see that he can ping the other server, but it doesn't belong to that organization. So this is a standalone server. I can install a DNS here. So you see, I don't have a role, but I can add role and features, next, 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 and I would just choose DNS. Here we go. Next, 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 and install. The role is installing. Okay, now it's installed. So if I go to tools again, I'm gonna find my DNS service available. And you're gonna see that there is nothing and absolutely nothing inside. It's empty, zombie, ghost, whatever DNS service is, right? There's nothing inside. Okay, so I can have a standalone DNS. So I'm gonna create my own new whatever. This is exactly the kind of DNS that we did in block 1. Okay, so it was a standalone server DNS. Well, let's say that this one gonna be a member now. Of course, to join any domain, we need to point that client to the DNS of the domain, right? And our DNS is 172, sorry, not the default gateway, talking about DNS. 172.24.101. Here we go. And all I'm gonna do here is change and join the domain as server, like I do with the clients, right? Like I do with the client, but he's a server machine. So my domain is originx.com, and need to provide some credentials here. Here we go. Restore. Once he's gonna reboot, he will be a member of the domain, like the client is a member of a domain. And he will not be a domain controller. He will not have any control over the others, but he will be a member on that domain. There we go. Having no control at all in this. So one more time, he will not be a DC at all in the. Oh, sorry. I'm gonna take this, guys. Give me 2 minutes. I will be back to you, right? Okay, sorry about that. I'm back. Okay, so the server started here, and we're gonna log in as like it's a client member, administrator, and query, and I will force him to go to the domain. You see that since there is the same name, administrator locally, so he switched to the local. So one more time, this guy is not a domain controller. He's a member server. He's a server who joined the domain like the clients do. So you see, to all DNS servers running on domain controllers in this forest, running on domain controllers in this domain, to all domain controllers in this domain. But there's no such a server that is not in the domain controller that's going to be kind of replicated automatically in there. Okay. I don't know why computers are shutting down because of the RAM, of course, but it's kind of dead. And merge here. Here we go. So you see domain originx.com. Here we go. Okay, turn off all the shit of this computer a second. Yeah, damn it. But you can see here that I don't have any Active Directory or anything. It's just a domain member, no more. So even if I go to Active Directory, The real one, if the computer is still running, of course, is not here anymore. It's shut down. God, shit. So as I said, there's no Active Directory uses in computers or dominant services, nothing here. I didn't promote this guy as a domain controller. So he's just a server member where I can have my DNS, and let's open the DNS. Well, we don't need this DCX2 for now. There we go. Wasting time for nothing. Machines that they turn off by themselves. Yeah. Okay, so here's my DNS. And you see that member servers still have nothing inside, right? So I still have nothing inside. This is not a domain controller. You don't have Active Directory, DNS zone, or whatever. It's just a DNS member where I still can custom and create zones here, for example. And that's it. I can even create a secondary zone of the Active Directory, right? So it will replicate here with all the, and people can use this one to log on since it's gonna have the records of the Active Directory Kerberos server, authentication server. I can point email server on that Active Directory one and so on. By gonna be a secondary here, okay? So this is my main domain controller. And let's add the roles here of Active Directory dominant services. So he was a standalone. Now he's a member server. And we saw the differences, right? Just join the domain here as any client can do. And there were no impact on the DNS at all. Okay, so when he's a member server, we can install roles and we can custom those roles, and he's gonna play those roles and for a specific service, and that's it. And even here in Active Directory, God, spending all the day waiting for the damn server to boot. Come on. So you see Rx here. Rx here is like station 1, X1 and station X2. So it's just a member. But you see the two DCs here, they have an NS host or a record here, but for both of them, see, here we go. And they are also named servers as DNSs for record. Okay. And if I go to Active Directory, that hopefully, please, if you may, open for a third time now. You see that computers have an RX a record for him. Dominant controllers, they still have just the two first before. So he doesn't belong to the dominant controller, he just belongs to the client computers, even if he's server. So member server, right? Member server. And we saw that there is no impact on the DNS when a server become a member server. Hopefully you're gonna finish today, not tomorrow. Please praise God for yeah, gosh. Take your time. No merge. We'll wait till he gonna boot. It's gonna take time. It's taking time. Sorry about that. I have no choice. While waiting. We're gonna see in the meantime where is the cryptocurrency market. Said everything bleeding and Bitcoin is look like he's dying. 44K. Okay, finally. Yeah, thank God. All right, so I can promote now this machine as a domain controller. And let's remember before we saw that I already installed the DNS as a standalone and I installed the DNS as a member server. And I will promote. So I will promote to add a domain controller to an existing domain. Yeah, hopefully that can find his calculus here. Yes. Okay. Again, maybe. All right. This computer is really taking forever doing these things. All right. Okay, we'll not spend all the day with this shit. Let's take a break here. It's 10 o'clock, right? So we're gonna go back 30 minutes. We will see the differences when this server. So I'm gonna just promote him when he will be able to be promoted, hopefully, during the break time, to another domain controller, and we will just check the difference again on the DNS. So all it matter here for us is the impact of that DNS right here. Okay, guys, if you have any question, please ask your question before we take a break, or otherwise I'm gonna let you on the break time. 30 minutes, we will come back. Keep your phone next to you. I will notify you on Kaizala. Any question? We're good? All right, see you in 30 minutes.